You are listening to The Vocal Technologist. Spoken tech for your ears.
Welcome back. If you're feeling anything like us, you probably feel like you need a special AI Mondays recovery day.
Oh, totally. Just to keep up.
Exactly, just to absorb the sheer speed of everything happening each week. It feels less like a tech cycle and, I don't know, more like building a house where they're pouring the foundation while already framing the top floor.
That is such a good analogy.
Hmm.
And look, for anyone actually trying to operate in this space, the real challenge is understanding these two massive things happening at once.
Right.
On one hand, you've got this absolutely unprecedented physical infrastructure arms race. I mean, buying land, securing power, it's nuts.
Yeah.
And then on the other hand, you've got these hyper-efficient leaps in the software architectures themselves. You really need to grasp both to figure out what's coming next.
That's exactly what we're aiming for today. We've gone through a stack of recent material, really focusing on that infrastructure insanity, these new efficiency models, and how it's all reshaping the economic ground beneath our feet. Let's start with the money, because the scale of investment right now is just, well, staggering.
We absolutely have to. I mean, the defining deal lately, the largest global data center acquisition ever announced, a massive $40 billion consortium buying Align data centers.
40 billion. With a B. And this wasn't just, some simple property flip. This was a huge group. Nvidia, Microsoft, BlackRock, and xAI all chipping in. And importantly, this is the very first investment from AIP, that's AI Infrastructure Partners. Their whole game is fueling AI data center expansion.
And what's really fascinating here, it's not just about the square footage. It's actually about power availability. We've hit this point where AI data centers are so desperate for electricity. Get this, they're planning to build their own power plants.
Wow, building their own power plants.
Yeah. Analysis shows the U.S. alone is projected to need nearly 80 gigawatts of new power starting in 2027, just for AI compute.
80 gigawatts. That's immense. And when the energy crunch is that bad down here, well, the solutions start sounding a bit sci-fi. Which brings us to StarCloud.
Right. StarCloud, they're actually proposing data centers in space.
Outer space data centers, okay.
StarCloud, they're part of the Nvidia Inception program, by the way. They're pushing ahead with plans to launch AI-equipped satellites to basically build data centers outside the atmosphere.
And the pitch is?
It's compelling, you have to admit. They're claiming 10 times lower energy costs, much better sustainability. They're planning a 5-gigawatt orbital center. The idea is to use constant solar power up there and the cold vacuum of space for cooling. It's a radical bet. Billions of dollars, basically saying, let's solve Earth's resource problems by leaving Earth.
Okay, from orbiting power to the chips inside these systems, the chip wars are really heating up, aren't they? And OpenAI made a pretty significant move here.
They certainly did. OpenAI is teaming up with Broadcom. They're going to design custom AI chips together, basically bringing a key part of their silicon supply chain in-house.
Right, taking more control.
Exactly. That collaboration is set to start late 2026, and just the news made Broadcom stock jump 10%. Shows you how much the market liked that. But this kind of strategic spending, it really highlights a huge financial paradox.
Yes, the big risk-reward question. Okay,
Right.
So you're betting $40 billion on buildings. You're committing to these multi-year custom chip deals. Who's actually footing the bill? Where's the money coming from?
That is the critical question, isn't it? OpenAI's expected revenue this year, around $13 billion, which sounds like a lot.
That's massive.
Until you compare it to these spending commitments, they're not actually expecting profitability until, 2029.
2029, so for the next 4 years.
So the next 4 years, the whole strategy hinges on, massive investor confidence. And this belief that the future payoff, maybe big enterprise deals, maybe government contracts, will justify the colossal debt they're racking up right now.
It's the ultimate build it and hope they pay strategy, dialed up to 11. And meanwhile, the GPU giants, AMD and Nvidia, they're fighting for every single rack space today.
Oh, yeah. And they're focusing hard on integration, on efficiency. AMD, for example, they partnered with Oracle. They're deploying 50,000 of their MI450 chips. That's a 200-megawatt cluster.
Okay. And Nvidia's answer?
Nvidia's countering with their Vera Rubin NVL144 architecture. It's this liquid-cooled, open-standard rack design specifically built for these these gigawatt-scale AI factories they envision.
And AMD's not standing still. They've got Helios coming, promising, what, 50% more memory than Vera Rubin?
Exactly, 50% more memory.
Yeah.
So, you see, the hardware battle, it's not just about raw compute anymore. It's being fought over better cooling, better memory density. It's getting sophisticated.
That's actually a perfect transition, because while hardware is this, $40 billion land grab,
Yeah.
the software, the new architectures, that's the precision engineering that makes that land suddenly worth 10 times more. We've got to talk about efficiency.
Absolutely. Let's start with Anthropic. Their recent release, Claude Haiku 4.5. It's just an immediate, really tangible example of this exponential efficiency jump.
Haiku 4.5.
It's genuinely a remarkable bit of engineering. Haiku 4.5 gives you the performance of their much bigger model, Claude Sonnet 4.
The expensive one.
Right. But it does it at 1/3 the cost, and it's twice as fast.
Yeah.
This isn't just like a small tweak. It fundamentally changes the cost of running these things.
Okay, wait. Twice as fast, third of the cost. Where's the catch? Is there some big engineering trade-off, or is this genuinely just better?
It seems to be largely a genuine breakthrough. Better model architecture, better quantization, and it enables completely new ways of working. So now you could use a big Sonnet model as your sort of expensive, high-level manager.
The injector.
Exactly. And it manages teams of these super efficient Haiku models working in parallel on specific little jobs. It just drives the unit cost of having AI agents way, way down.
That really speeds up the whole multi-agent system idea, which leads right into their other new thing, Claude Skills. You mentioned this could spark a sort of Cambrian explosion for automating business tasks.
Yeah, I think it could. It totally changes how you load context into the model. See, Claude Skills are these modular packages, right? They hold specific instructions, maybe scripts, resources.
Like little toolkits.
Kind of.
Yeah.
And they only use up a few dozen tokens until the model actually needs that specific skill. Older ways. You might burn tens of thousands of tokens right at the start, just loading everything up just in case.
So the AI isn't reading the entire instruction manual unless it actually needs page 37. That sounds incredibly cheap, compute-wise.
Exactly right. And the design is brilliantly simple. You literally just drop the instructions into a special folder, and Claude figures out when to pull them out and use them. This basically transforms Claude Code from just a coding assistant into a true general automation agent. It can do anything you can normally do by typing a command or, dropping in a file.
Incredible. Okay, so text is getting way cheaper and more capable. Meanwhile, video generation is also hitting some big new milestones, right? Google VO 3.1.
Yes, VO 3.1 definitely shows a noticeable step up, especially the audio output. It matches the visuals much better now. And it seems to understand complex text prompts with more nuance.
More sophisticated.
Yeah, they've added things like really fine-grained control over specific objects in the video and better ways to blend existing images into new video content. It's moving from just cool little clips towards something you could actually control and edit for, like proper production work.
But speaking of control, let's talk about that problem everyone's noticed. Mode collapse, where the AIs just keep saying the same boring generic stuff that the researchers literally called it the same coffee joke problem.
Yeah, it's the same coffee joke. It's a real thing. And it basically comes from typicality bias in the training data. Meaning, during training, the humans rating the AI's answers tend to prefer familiar, average, safe responses. So unintentionally, they train the models to be repetitive and, well, a bit boring. But the fix, called verbalized sampling, is one of those genius ideas that seems obvious once you hear it.
And that just involves asking the model to give probabilities along with its answers?
Pretty much. You ask it, say, generate 5 answers and tell me the probability you think each one is good. By forcing the model to think about the probability landscape of its options, you push it out of its safe little rut.
Makes it explore the weird stuff.
Exactly. Explore less typical, but often more creative possibilities. And get this. This simple technique boosted creative diversity by about 2 times. And human ratings on complex tasks like story writing went up 26%.
Wow, that's clever. Quick question, though. Does making it generate probabilities add a lot of extra computing time? Is this creativity making it slower?
Surprisingly, no. The extra computation is tiny compared to the huge improvement in quality and diversity. So it's a really cheap trick to implement. Massive win. Okay, now let's shift gears a bit to the underlying intelligence itself. The next big step in scaling inference seems to be recursive language models, RLMs.
Recursive language models. Okay, that sounds theoretical. Can you ground that for us? The description is they decompose and recursively interact with context.
Yeah, that's the academic way to put it. Let's unpack it. Think of it like this. Instead of reading a document once and then answering your question.
Standard approach.
Right. An RLM can break your question down into smaller parts. It can then run subqueries, almost like asking itself questions. Then, crucially, it can go back and reread the original text based on the answers to its own subqueries. It creates this kind of self-checking, verifiable chain of reasoning. It's just fundamentally better at complex, multi-step thinking.
Okay, that makes sense. A model that sort of double-checks its own work as it goes.
Precisely. And we saw a study where an RLM, even using a smaller base model like GPT-5 Mini, actually outperformed a regular full GPT-5. It got more than double the correct answers on a tricky benchmark called Oolong.
Double the correct answer.
And on average, it was cheaper per query, because it was more accurate the first time, less back and forth needed.
Right.
So it's recursive reasoning. It's widely expected to be the next major scaling milestone for getting towards more general intelligence.
Okay. So just recapping, we've got gigawatt scale infrastructure being built,
Yep.
hyper-efficient software like Haiku,
Right.
and now these recursively reasoning models coming online. Let's pivot now to the impact. The economic and societal footprint these transformations are leaving. This is where it really hits the job market, right?
Yeah. The job displacement picture is getting, well, starkly clearer.
Yeah.
OpenAI themselves project that models at the GPT-5 level can match human professionals on roughly half of all economically valuable tasks,
Half.
and completing work that takes a human hours in just minutes.
And OpenAI's response to that is proposing this huge retraining program, targeting 10 million Americans by 2030. They frame AI as the great enabler, but there's a lot of debate around whether that approach actually works, historically speaking.
There is. I mean, while OpenAI is putting resources forward, economists will point out that historically, big retraining programs have really struggled to keep pace with technological disruption, especially for people already mid-career. We're just reporting on that tension, impartially. The debate itself is important.
And to tackle that wealth distribution challenge more directly, Anthropic gathered some policy proposals. Things like $10,000 annual training grants paid by employers.
Right, or token taxes on AI-generated content. Maybe the most interesting one, setting up sovereign wealth funds so every citizen gets some kind of stake in future AI revenues.
That's a big idea. And speaking of content, that statistic about digital content was sobering.
It really was. An analysis of, 65,000 web articles found that AI-generated content actually overtook human-written articles back in November 2024.
November 24. So it went from basically 0 to almost 40% of articles analyzed?
39%, yeah.
In just the first year after ChatGPT became widely available, AI has basically taken over online content volume already.
Pretty much.
And if we look past the web into core manufacturing, there are these hidden industrial bottlenecks most people don't even think about.
You're talking about geometry kernels?
Exactly, geometry kernels. This is the really specialized software that manages all the precise math inside CAD software computer-aided design.
Okay, and why should someone listening to, say, the vocal technologist care about some specialized math software?
Because it's strategic infrastructure. It's currently dominated globally by just a handful of proprietary companies.
And the consequence is control, right?
Yeah.
If you can't access or modify or build competitive kernels, you're limited. You limit your ability to design the next generation of, jet engines, advanced robots, complex microchips.
So the argument is?
The argument is strong that if places like the US or Europe want to stay competitive industrially, they might need public investment to create an open-source alternative. You can't have these fundamental industrial building blocks locked up in a few closed systems.
Yeah, it's a really fascinating layer of control most people miss. Okay, finally, let's touch on consumer integration. This is moving beyond just chatting, right, into actual buying stuff.
Absolutely. We're definitely seeing the start of real conversational commerce.
Right.
Walmart, for instance, they've teamed up with OpenAI. You can now make purchases directly through ChatGPT using this instant checkout feature.
And that gives OpenAI a cut, right? A transaction fee.
Exactly. A new revenue stream, making the chat interface directly profitable for them.
That feels like a pretty big step. And it brings us to what you called the App Store moment, when you can just say, hey, Spotify, make me a playlist for this mood, or DoorDash, order my usual, and the app just does it right there inside ChatGPT. What does that signal?
It signals a fundamental shift, a move towards true native conversational apps. As OpenAI expanded its tools for developers, giving them access to things like user memory, persistent state, so the AI remembers you and your preferences.
And knows who you are.
Right. We're seeing the birth of apps designed from the ground up for a conversational interface. Just like, The early apps on the iPhone signaled that shift to mobile-first experiences 15 years ago.
Okay, so bringing this all together, we've got this $40 billion infrastructure and power race.
Yep.
Colliding head-on with incredible efficiency gains like Haiku 4.5 and this recursive intelligence leap. It's a transformation happening on two tracks, hardware and software simultaneously, and the scale is just unprecedented.
It really is. And that pace is why policy often seems to be playing catch-up. We should quickly mention, though, governance is starting to react at the state level. California's SB 243, for example.
Ah, the chatbot law.
Right. First state law to specifically regulate AI companion chatbots. It mandates things like age verification, clear warnings, trying to protect vulnerable users. So we are finally starting to see some legal accountability for these direct-to-consumer models.
A necessary step for sure. But I want to leave folks with a final thought, really, about the challenge this poses for management, for how organizations think. We've spent decades training business leaders that software errors, a missing semicolon, a bug you can trace, have fixes, permanent fixes.
Right. Bugs have causes you can find and solutions that stick. That's the whole IT management model we've relied on forever.
But AI failures, they don't work like that, do they? They emerge from patterns in trillions of data points. You often can't trace them to one line of code. A fixed behavior might just pop up again with a slightly different prompt. Sometimes even the labs that built the models don't fully get why an error happened.
It's a black box problem.
Yeah.
Fundamentally.
Exactly. So here's the question for you to think about. If your boss, your organization, assumes AI errors are just like old software bugs, patchable, understandable, fixable, how long until an untraceable, maybe catastrophic failure forces a complete, probably expensive rethink of your entire safety and risk model?
That is definitely food for thought. The very nature of this tech, it demands a whole new way of thinking about risk.
It certainly does. Okay, that's all the time we have for this discussion. We'll catch you next time.
Spoken Tech, for your ears.